Example 6, we're trying to find the coordinates of any points where that function has a horizontal tangent line. So reading the question carefully is always a good first step, if not a good last step, right? When in doubt, read the instructions. First of all, it says coordinates. Coordinates. Co means what? Together, sharing, right? So there should be two ordinates here that we need to find, right? Maybe an x and a y. So that means x comma y of any points where the function has a horizontal tangent line. So you always want to kind of map out your strategy. If you want to know where the function is a horizontal tangent line, you need to see where the what equals what. F prime equals 0. Good. So there's your plan. All right. So before I can set F prime equal to 0, I need to find F prime. And I spy a product rule. How about you? Good. So here we go. Don't forget the left side. F prime of x equals. The derivative of x is 1 times e to the x goes along for the ride, yeah? Plus x goes along for the ride times the derivative of e to the x, which is e to the x, right? Good. Now, if anyone walked in right now with a keen understanding of the product rule, but they didn't have any idea how to take the derivative of e to the x, they might think that we just wrote down the second term without taking the derivative of the second factor in that second term, right? So we'd be like, learn your derivative rule, man. It's easy. If that were to happen, that's what we would say. We'd be prepared. All right, let's go ahead and set it equal to 0. Of course, once we set something equal to 0, our goal is to say it. F it. Yeah, we factor it. In a math class, that's what it means. So we factor out the e to the x, and we get 1 plus x. And of course, then I would set each of them equal to 0. And for what value of x is e to the x equal to 0? No value of x is, yeah, e to the x is a horizontal asymptote at 0. So this little piece has no solution. And 1 plus x, I guess, is when x is negative 1. Now that I've found negative 1, I need to find its coordinate. So the ordered pair of the point is going to be negative 1 comma f of negative 1. And all I have to do is plug that back into the y value machine, which will be negative e to the negative first. Now, is negative e to the negative first the same thing as positive e? No. Is it the same as e? Yes. Yes, it is. So either one of those would work. All right. Moving on here. Example 7 says to find the equation of the tangent line. Tangent line. What do I need for the equation of a tangent line? Slope and a point. I got the point. All I need is a slope. Halfway there. We're halfway there. Oh, nice. Yeah. I have to agree, though. It does feel like we're a little bit kind of like we're at Disney World, huh? We're just having that much fun. Was that a Mickey voice or was that something else? Okay. All right. Hey, what do we need to take the derivative? Is it solve for a y in terms of x explicitly? Yeah, it sure is. Now, if I size it up here, I've got three terms. Normally that excites me, but I got a product rule in the first, a product rule in the second, and no product rule in the third. So maybe if I simplify early and often, maybe this would be the time to try and simplify early. Is there anything we could do here that will help us when differentiating? Anyone see it? Factor out an e to the x, so it's just y equals still. And we're left with x squared minus 2x plus 2. And now it's just one product rule. Yay! Unless you like the product rule, then boo! Right? So here we go. The left side becomes y prime or dy dx. And the derivative of e to the x is e to the x times the second. And if we stop right there, that would confuse people, right? You mean y and y prime are the same? Let's not stop there. Plus, now e to the x goes along for the ride, times the derivative of the second factor, which is a polynomial. We get 2x minus 2. X minus 2. Now, normally, I would say go ahead and plug in immediately after you take the derivative because you're after a numeric value. But I just irresistibly can't help but factor out that e to the x before I plug in. So let's just see what that would do. If I factor out that e to the x, this is where I usually put the beefy brackets, because now I have a bunch of stuff left over. I'm left with x squared minus 2x plus 2 in the first term. And in the second term, I'm really left with just a positive 1, which there's really nothing to distribute. But had that been a minus sign, you would need to carefully distribute. So we're left with just plus 2x minus 2. Now, was it worth simplifying? I think it was in this case, because notice your 2x's cancel, and your 2's cancel, and you're just left with x squared. Oh, man, that's a charming-looking derivative. Now, all we have to do is plug in a what for x? A 1 or an e? A 1. Now, here's again, when you're shifting from, or switching, I should say, from a variable function of x to a numeric value of 1, you need to put y prime of 1. You don't need to put y prime of x, but you need to put y prime of 1. And then you get e to the first times 1 squared, which is e, right? E the number, not e the letter. Now we're done. We have to be done. We've done a lot of work. We must be done. That's how we know, right? Oh, we didn't write the equation on the line. Okay, so good. Now, it did say tangent line, not normal line, right? So here we go. Y equals, in Taylor form, the y value of e plus the slope value of e times x minus 1. Taylor form, box it up, walk away. Maybe even label it as the equation. You don't even have to box it up. Now, again, irresistibly, I'm going to distribute. I get e times x minus e. What happens with the e's? They cancel, and I'm left with e times x. Now, notice that is not e to the x. That is e times x. The tangent line is a line with a slope of e. X. It looks like x. Like executive, examination, exchequer. Ex-Marine? No. Former Marine. There are no ex-Marines. Any questions on that? Okay. Let's let y'all chew on the last one, and I'll meet you here in a second, okay? It says to find dy dx for that Q or anything, you're just going to have to guide yourself. You know what to do. You can do it.